Okay, so this is the 1-4A notes for Algebra 2. We're looking at the inverse composition law and the linear inverses. Okay, so what is an inverse? It's a function that takes an input and does something to it and then gives out an output. So that's what a function does. And a function's inverse takes the output that you got from the other one and then gives us back our input. So let's say you put in 50 cents into a soda machine and you got the soda out, that would be your function. The inverse of that would be putting the soda out back into the soda machine and getting your quarters back. So wait, I don't speak math. Well, I do. So let's say you have f of x is 0.5x plus 1, and we put 4 in, and we would get 2 plus 1, and that would solve, our answer would be for x is 4, y is 3. Our input's 4, our output's 3. Our g of x is 2 times x minus 2. We put 3 into the g of x where x is, so 2 times 3 minus 2. And when we solve, we get back 4. So that means f of x is the inverse of g of x and vice versa. So our input was 3, our output's 4. Okay. So inverses are things that you get when you give functions happens when you put something in, you get something out. And inverse happens when you put what you got out back in, you get what you started with out. So composition of functions is a fancy way of saying what we just discovered, that two functions are inverses of each other if their composites equal x, if you get back what you started with, your x. So f of x, f of g of x is how you would write a composition. We sometimes also call it f of g of x, where it looks like the word fog, but we read it f of g of x, okay? That's just a way of putting things together. So we're going to do a composition of functions. An example using our previous functions, we have f of x is 0.5 of x, 0.5 times x plus 2, and g of x is 2 times x minus 2. So let's say we put g of x into where x is on our original function. That means take 2x minus 2 and replace the x in the f of x function. And then we solve down until we find out that f of g of x is equal to 2. We can do it the other way by taking the f of x over here, take this whole function over here and plug it where x is here. That's what this is saying. So we put 0.5x plus 1 where x used to be, go ahead and do the distributing and adding up, and we would get x is positive 2, or g of f of x is x. If both of them, actually, usually you can say this, if one happens, then the other one will happen, but you always want to check both just in case you may have made an error the first time. So finding linear inverses of linears, there's a couple of steps. First one, we're going to change our f of x to a y. Step 2, we're going to switch our x and y spot, and then we're going to solve for y. We do that by using PEMDAS backwards. I call it SADMIP. And then we replace our y with f to the negative 1 of x. That is the symbol. That's the symbol for negative 1. So that's the symbol for an inverse. So let's do it with g of x is 2x minus 2. We're going to change g of x to y. We're going to swap where x and y are sitting. So x becomes y and y becomes x. Then we're going to solve for y, which means get y by itself. First, we have to add 2 across. So it becomes x plus 2 equals 2y. Then we have to divide by 2. And that gives us 0.5 because x divided by 2 is 1/2 x. 2 divided by 2 is 1, so we get 0.5x plus 1. And we change that to g of negative 1 of x, the f of x we started with, okay? So that's just pointing to all of the steps and letting you know what to do. Okay, so let's look at a couple other examples real fast. We want to write the inverse of the function. The function has all of these different points. Well, when we write a function, when we write the inverse, we actually are looking at the, we have to take our points values, your x and y's, and we have to swap them. So for -4, -3, our answer would have been -3, -4. The two x and y's will swap. Same thing here. -2, -4 becomes -4, -2, -2, 0, 0, 1, and 3, 2. So see how the x's and y's just switched. So now that I've shown you an example, I want you to do it for number 4. Okay, so you should have picked that -4, 3, -3, -3, -2, 2, -1, 2, 1, 4, 2, 4, 3. I want you to notice something. None of the signs change. The numbers kept the same sign they had. So -4 is kept -4, -3 kept -3, -4, -2. No signs changed, just their positions changed, just whether they were X or Y. Okay, so we're going to find the inverse of this function. You can see the actual graph here. There's a reason why there's a dotted line on there. That is not this function. That is the y equals x. When you find an inverse of a function, when you draw this function and its inverse, it will look like it's mirroring across that diagonal. Okay, not the xy, not the x and y axis, but that diagonal. So it will look like if you folded that diagonal over, you would have it on top of each other. Okay, so follow the steps that we went over a few minutes ago to find the inverse of this one. So if we replace f of x with y and then solve for x, we get f of x is negative 2x plus 3 becomes y equals negative 2x plus 3. We solve for, they're saying solve for x, but basically the step is switch our x and y. So they actually did it afterward. So if you want to solve for x and then switch your x and y's, that's fine too. But notice that you have f of x is this line here, and this line looks like it's reflecting. So technically this short area gets reflected, and that becomes this short area. This long one becomes this long one. That's why you can see that they're actually folded, they're reflecting over. It's hard to tell when they're short and long, but the long becomes long, short becomes short. You have to match them up. Uh, okay, so here's the second problem. Go ahead and do this one. All right, so you should have gotten the f of -1 of x is negative x plus 3 over 2. Oops. Okay, so for another way we can do this is we can look at the inverses of the domains. So here's a swimming pool has 600,000 gallons of water is drained. We have an equation of 600 minus 20t, and we want to find the domain of the inverse. So I'm just going to run through this to kind of give you an idea. The domain of the inverse is the range of the original. So if we know what the range is of the W 600 minus 20t, then we know what the domain of the inverse would be. So the domain is going to be from 0 to 600 for the original one, and the range is going to be from 0 to 30 to 0. Okay, or 0 to 30. So the range of the inverse is going to be the domain 0 to 600 of the original one. And then we would just use our math to find it, and then you would have, so the domain of the original is going to be the range of the inverse and vice versa. And that is all of the problems. So I'm just going to ask you to get, instead of doing problems, I'm going to ask you just to acknowledge that you finished this one. We're running out of time.